We are living in a golden age of astronomy where NASA's Hubble Space Telescope and an armada of other observatories are exploring myriad galaxies, stars, and planets across the universe. The pace of discovery is accelerating. Vast amounts of astronomical data are being harvested and archived at a much faster rate than astronomers have the time for analysis. This means exciting new discoveries are waiting to be uncovered by future researchers who dig into the gold mine of stored astronomical data.
About a third of the papers are coming out of the new data that HST takes. About 2/3 of the papers, the HST papers that are being published today use archival data.
Besides 2 decades worth of Hubble data stored here, the archive is also home to 15 other NASA astronomy missions, stretching back to the 1970s. The archive hosts data from early pioneering space missions like the International Ultraviolet Explorer and the Copernicus Observatory. More recent additions are ultraviolet-light views of galaxies from the GALEX mission and hundreds of far-flung planets from the Kepler Observatory.
The archive is especially important for my research because I study things that explode in the universe. I'm interested in how things change with time. So with the archive, I can look at that history of observations and find what telescopes happen to be observing that part of the sky when the supernova exploded.
Archival data is very important for my research. I'm trying to image and discover planets around other stars than the Sun. And in a recent result, I was able to measure the motion of planets around a particular star by looking 10 years back in time using archival data.
Supernova 1987A was the first naked-eye supernova in 383 years. It's now 10 million times fainter than it was in 1987. We've never observed a supernova this early in its life, when the debris of the exploded star is just starting to be able to be spatially resolved. It's a completely unique phase for astronomers.
Nobel laureate Adam Rees found the archive invaluable for helping him understand the nature of dark energy.
We needed to look back to an earlier phase in the universe, see if the universe was slowing down before it began speeding up. And I looked through the archive and found what turned out to be the most distant supernova ever seen. And I was able to make a very important measurement that confirmed what we had seen.
Because of the internet and a powerful search engine, using the database is easier than ever. When the MAST was unveiled in 1990, it took a week or longer to fulfill a request. Now it's just minutes. And it's not only astronomers who access the archive.
It's given me the possibility of having students do projects that require actual astronomical data without allowing them to have access to a telescope at the same time. The archive provides a ready source of excellent quality data, but it's not prepackaged. They still have to sort it out just like they would data from a telescope.
As revolutionary as the Hubble Space Telescope has been, its greatest legacy may well lie in the archive that stores its data. With more missions to be added to this astronomical library, like the upcoming James Webb Space Telescope, astronomers expect groundbreaking science from this archive to continue many years after these missions end.